Hi everyone, welcome again to my channel, Math is Fun channel. This channel is an educational channel to help you understand your lessons in mathematics. This channel is intended to those who are doing the online classes out there and also those who are answering their modules. This will help you understand your lessons in mathematics. Please do not forget to subscribe my channel rather, and of course, please do not forget also to share this channel to your friends out there so that you can help them also develop and improve their performance in mathematics. So are you ready in our next video discussion or our topic for today? I guess you're all ready, so we can now start. Our topic will still be in the measures of central tendency, but we will have an in-depth lessons or learnings about measures of central tendency. As you can see there on the screen, our lesson will be measures of central tendencies. So as a definition, things that we need to remember in the measures of central tendency, when we say the mean, we call it the average. It is the sum of a set of data divided by the number of data. Do not round your answer unless directed to do so. So take down note of that. But we made it standard about our answer in here so that we have a basis. So as possible, you can have two decimal places as you can or that you can use in your answer of your mean. So please do not forget about that one. Another thing also under measures of central tendency, we have the median. So the median is the middle value or the mean of the middle two values when the data is arranged in numerical order. And of course, the mode, the last statistical tool for the measures of central tendency, we have the mode, and then the mode is the value or number that appears the most often. It is possible to have more than one mode. Take down note. We call it bimodal. And it is possible to have no mode at all. If there is no mode, write no mode. Do not write zero, okay? Do not forget that one. If there is no mode, just write no mode. Do not write zero. I hope you'll be able to grasp that. And of course, another thing also, we will just take this one, though it's not really part of the central tendency, the range. The range is the difference of the highest and lowest value. In short, highest score minus the lowest score. That is how you get the range. For the mid-range, it is the sum of the highest and lowest values divided by 2. So you add the highest and the lowest value and divide it by 2. Then you can get the mid-range. Do not forget about how you get the range, how you get the mid-range, and of course, how you get the mean, median, and mode. So now let's start with the mean. So how to get the mean again? So a mean, as I have said, as I mentioned a while ago, it is the average of the given set of data. So for the advantages for the mean, it is most popular measures in fields such as business, engineering, and computer science. So that's one of the advantages of using the mean in central tendency or measures of central tendency. Why? It has a unique answer, or it is unique, or the mean is unique. There is only one answer. So as you can observe. Another thing also, one of its advantages of using the mean is it's useful when comparing sets of data. The mean is very useful when comparing sets of data. So what's the disadvantages or disadvantage of using the mean? It is affected by extreme values, or you call it outliers. Again, outliers means the extreme values in a given set of data. So in short, one of the main disadvantages or disadvantage rather of using the mean is it will be affected right away if you have extreme values, or you call it outliers. So if there is or if there are outliers, then the using the mean is not, or it will be affected, or it is not reliable to use when there are outliers, or if it exists, or if there is an extreme value that exists in our given set of data. Take down note of that. A mean is affected by extreme values. So it is not most reliable to use the mean if there are extreme values or outliers. Okay, so next, the formula for the mean, as I have mentioned in our previous video discussion, we have the summation of x over the n. Summation of x means you're going to add them all, the total number of scores that you have, then divide it by the number of scores or data that you have. So next is the median. So median, one of its advantages, it is, or the extreme values or outliers do not affect the median as strongly as they do the mean. Remember, as I mentioned a while ago, when there are outliers or extreme values, mean is not reliable to use because it's affected by the extreme values. However, using the median or the median are not affected by the extreme values or the outliers. So if there are outliers in a given set of data, then do not use the mean. Instead, use the median, because the median, as I have as projected there on the screen, it is mentioned that the extreme values or the median will not be affected by the extreme values. So we can use the median when there are extreme values. Another advantages for using the median, it is useful when comparing sets of data. So when you try to compare two sets or given sets of data, then you can also use the median. Another thing also, same with the mean, a median can be, or one of its advantages is, it is unique. There is only one answer. Same with the mean. The only thing in here for the median, you can use this one when there are extreme values because it will not be affected by the outliers or extreme values, unlike in the mean. So disadvantages for the median, as you can see there on the screen, it is not as popular as mean. Yes, everything or in our world, we commonly use the mean instead of the median, correct? But make sure that you know when and where to use the mean and when and where to use the median. Another measures of central tendency is the mode. The mode there, one of its advantages, of course, extreme values or the outliers do not affect the mode. So you can either use the median or the mode when there are extreme values. So it can be used for non-numerical data, colors, and etc. So these are the advantages of using the mode. Disadvantages. So listing all the disadvantages for using the mode. It is not as popular as mean and median, of course. Not necessarily unique. Maybe more than one answer. Remember, we have bimodal, trimodal, so or even no mode at all. So mode, that's why mode is not necessarily unique. It may be more than one answer. That's why that's one of its disadvantages. Another thing also, when no values repeat in the data set, the mode is every value and is useless. So mode is useless when there are no um, there are no values that repeat in the given set of data. So that's one of its disadvantages. And another, or lastly, when there is more than one mode, it is difficult to interpret and or compare, right? Unlike in the median, a mean and median. So I hope you'll be able to grasp the concept when and where to use the mean, median, and mode, especially their advantages and disadvantages, of course. Okay, so what happens if we replace the lowest grade with a zero? That sounds interesting. So example, you have a given set of data, 65, 70, 75, 76, 77, 80, 82, 84, 86, 89, 90, 92, 93, 95, 97. What if you are going to replace the lowest grade, this 165, we will replace it with a zero? What will happen to median and the mean? I want you to to observe that for a while. Okay, replace 65 or the lowest grade or score with zero or with a zero. What happened? I want you to compare it. Is the median affected? Is the mean affected? So based on the screen that you can observe there, when we try to replace the lowest grade with a 0, then the median will not be affected, but the mean is affected. See, 84, the median, when we replace 0 in here, the median still the same, 84. But when we try to compute its mean from 83.4, yeah, it went down into 79 rather. So meaning to say the mean is affected. This is what I said. When there are extreme values, mean will be affected, median will not be affected. So I hope you can relate. So now, next is what will happen to the measure of central tendency if we add the same amount to all data values or multiply each data value by the same amount or number. So let's see, let's try to observe. This is the original set of data. Then we have the mean, 12.2, mode is 14, median is 13. So try to observe and compare. When we add to each value, we add it 3, 6 plus 3, 9, 7 plus 3, 10, so on and so forth. What will happen to the mean? Of course, the mean will increase. Of course, it's very pretty obvious. And the mode will also increase or change, correct? And then the median will also increase. That's pretty obvious. Now, next question. What will happen to each data value when you multiply it? Or what will happen if we multiply 2 times each data value? So from 6, multiply it by 2, that gives you 12. 7, 14, 8 times 2, 16, so on and so forth. So the mean will, of course, will be doubled. See, the mode will also be doubled. Median will also be doubled. So when you try to multiply it, the data, then the original, if you compare the original and then the one that you multiplied, the mean, mode, and median will be either, it depends upon the number that you will multiply. If you multiply it by 3, of course, it will be tripled. Okay, so on and so forth. But of course, when you try to add each data set value or data value rather with a 3, then of course it will also increase the mean, median, and mode. I hope you will be able to grasp the concept behind it. So now let's proceed to the next slide. So here are another thing rather for distribution of data set. So as you can see, skewed to the left is negatively skewed, meaning to say, when I say skew, this is the skewness of the line. This will give us or will describe us about the distribution of the data. When median is greater than the mean, expect that the skewness of the graph will be skewed to the left, as you can see. If it is skewed to the left, that means we have a negatively skewed. That will happen again when median is greater than the mean. I hope you can notice that and you will not forget it. What will happen if the mean is greater than the median? This one. When the mean is greater than the median or median is less than the mean, what will happen? Okay, the skewness of the graph or the line will be skewed to the right, as you can see, this one, the skewness of the graph. And of course, it is positively skewed. Again, this will happen when the mean is greater than the median or the median is less than the mean. So I hope you can describe it and you have noticed it. Another thing also, when the distribution of data, or what I mean is when the mean, median, and mode, they are all equal. In short, mean is equal to the median and median is equal to the mode, then our graph will be symmetric. So this one, symmetric. So this is a normal distribution. So the skewness of the line will tell us or will describe us the distribution of the data set. Again, when the median is greater than the mean, it's skewed to the left, meaning to say negatively skewed. When the mean is greater than the median, then it is positively skewed. It's skewed to the right. But when the mean is equal to the median and median is equal to the mode, then that gives us a symmetric graph or the normal curve in the distribution of our data set. So I hope you'll be able to remember these concepts. Okay? Okay, so now let's have an example. Find the mean, median, mode, range, and mid-range for the following data set. Remember the formula that I mentioned a while ago? So you have it 5, 15, 10, 15, 5, 10, 10, 20, 25, 15. Again, first, before you get the measures of central tendency and getting the range and mid-range, you have to organize the data set. You have to order them from smallest value to largest value, as what you can see there. So we order them from smallest to largest value. Next, of course, to get the mean, you have to sum it up, add all the data set, and divide it by the number of data that you have. We have 10. There are 10 of them. So 130 as a total, divide by 10, that gives you 13. Of course, that's the mean. To find your median, so you already arrange it. So how many are they? There are 10. This is what I said. You have to get the midpoint. So of course, half of 10 is 5. So you will count 1, 2, 3, 4, 5. So this one. On the left side, 1, 2, 3, 4, 5. This one. Therefore, the median will be located in here between 10 and 15 since the given set of data is even number. So you add it 10 divided by 15, divide by 2, that gives you 12.5. So listing the data in order is the easiest way to find the median. The numbers 10 and 15 both fall in the middle, correct? So in getting its median, since it's even, so you will just get or take its average of the two numbers to get the median. You have, as you can see rather on the screen, 10 plus 15 divided by 2, that gives you 12.5. For the mode, of course, two numbers appear most often, the 10 and 15. There are 3 10s and 3 15s. Therefore, there are two modes in here. We call it bimodal. To get your range, just take the highest score and, of course, the lowest score. You have to subtract it. Get its difference. That gives you 20. That is your range value. And for the mid-range, of course, get its average. So 5 plus 25. Highest is 25, lowest is 5. Add it, that gives you 30. Divide by 2, you have it 15. This is your mid-range. So I hope you'll be able to remember the concept about getting the mean, median, and mode, including the range and mid-range. Okay, so now let's proceed to the next slide. So the next slide, it's about example number 2. On his first 5 biology tests, as you can see, Bob received the following scores: 72, 86, 92, 63, and 77. What test score must Bob earn on his 6th test so that his average or mean score for all 6 tests will be exactly 80? This is how you estimate your average to get an average of 80 after all. After getting these grades, 72, 86, 92, 63, and 77. Show you how you arrived. I will show you how we arrived in this, the answer of this problem, or in this problem rather. So, possible solution or method, set up an equation to represent the situation. So of course, remember to use all 6 test scores. So you have it 72 plus 86 plus 92 plus 63. And then we add x because we don't know. This is what we are looking for. Divide by 6 because you are going to look for the 6th test score for or grade for of Bob in biology. So you have it equals 80. This is our target average. So you will just multiply it 6 times 80, and then you just add them all. So to show the full solution that we have in here, we can, oh, sorry. So you can just have it 80 times 6 for a while. Let's just have to compute this one. You can use calculator if you want, but if you can add it using your mental capacity, then you can have it. 80 times 6, that gives you what? 480. Sorry. 480. And of course, 72, you add them, this one 72 plus 86 plus 92 plus 63 plus 77. I want you to answer it and solve it on your seats. As you listen in this video discussion, I'll give you time to do it so that we can solve it together. Okay, so you have it 372 plus 86 plus 92 plus 63 plus 77. That gives you 300, sorry, 390 plus x. Okay, then after that, you can just have it 480 minus 390. Transpose it to the other side. So your x now becomes the value that you need to get in order to get an average of 80 is what? 90. So Bob must get a 90 grade score rather in his 6th test so that he can have an average of 80 in its mean score. So that's how you do it. I hope you'll be able to grasp the concept. How did we do it? Okay, so now let's have another example for the group data. On statistics, sorry, we have advertisement coming from outside world. So going back to the example that we have in the group data, on a statistics examination, 7 students received scores of 95, 9 students received 90, 6 students received 85, 4 students received 80, there was 175, 3 students with a 70, and 1 student received 65. The mean score on this examination was nearest 10. So now what will we do for the group data? Of course, you have to make a table. So using the frequency table of test scores, find the mean, median, and mode range and mid-range. So how you do it? So we can just have a separate discussion about this one for the group data, since our focus in this video discussion only for the ungrouped data. So let's proceed to the box and whisker plots. Determine the box and whisker plots. It's used in statistics. It will help us determine the 5 key values. What are these 5 key values? First, the 5 number summary, the minimum value, the maximum value, the median or the second quartile, or we can name it Q2, and the first quartile, which is the median of values less than Q2, below the median, or you call it below the median. And of course, the third quartile is equal to the median of values greater than Q2 or greater the median. Okay, so again, the box and whisker plots will help us determine and describe these 5 key values. Do not forget, Q2 is the median. Below the median, we call it the first quartile or less than the Q2. And upper or above the median, you call it the third quartile or greater than the Q2. So I hope you can grasp and you can follow. So that is the box and whisker plot. So more of it, the interquartile means to get your interquartile range, you will just subtract Q3 and Q1. So in short, Q3 minus Q1. Quartile 3 or third quartile minus the first quartile. So I hope you can follow. Now let's try to use it so that you can appreciate it. Construct a box and whisker plot for the following data. You have the math test scores 80, 75, 90, 95, 65, 65, 80, 85, 70, 100, as you can see there on the screen. This one, yes. So how to make or how to make and draw our box and whisker plot. how to do it, or how to make box and whisker plot. So first is, of course, you have to arrange the data, right? As I have said a while ago, from smallest to um, largest value. As you can see there, it's arranged already in here. Then after that, you identify the median first. This is the step number one. Identify the median. So of course, the median is located, since the data is even, the median is located in here between 80 and 1880, of course. This is already your Q2, or the median. You call it the second quartile. That's why 80 is our second quartile. And of course, below the median from here, going in here, so that is your median of lower part, or you can get your first quartile from 80 down to 65, since first quartile is being described as the lower of the Q2. So from 65 to 80, of course, the median in here is the 70. That's why the first quartile is 70. Okay? So I hope you can follow. Again, from here, going in here, 70 is the midpoint. That's why it is your Q1, or quartile 1, or first quartile is 70. So do not forget. To get your third quartile, that is upper of your median. So this is your upper median, or upper or greater than the Q2, or second quartile. Again, the second quartile is your median. So 90 is the median in here. So the median of upper part is the third quartile, which is 90. That's why the third quartile is 90. And to get your minimum value, of course, minimum value is 65. The smaller value, the maximum value is 100. So please take down note of these. So in short, to construct a box and whisker plot, you need the following: the median, or the second quartile, the first quartile, third, minimum, and then the maximum value, as I have said a while ago. So I hope you will be able to remember that one. These are the things that we need in constructing a box and whisker plot for the given set of data. So now, next, after we identify it, the 5 key values, as I mentioned, we can now create a number line and plot values below it. So I will show you. Okay, this one. You can make a number line. You can make it as a number line and then put a plot values in there. After that, we have to draw a box with ends through the points for the first and third quartiles. Then draw a vertical line through the box. At the median point now, draw the whiskers or lines from each end of the box to these minimum and maximum values. So how? How to follow it? Just follow this one. So this is what we do. This is what I said. Draw a vertical line. Again, first draw a box rather with ends through the points for the first and third quartiles. So the first and third quartiles, this one, draw the box as you can see. Okay, then draw a vertical line. This one, the vertical lines, as you can see, the vertical lines. And then now draw a whisker or lines from each end to the box. This one, the line connected. Okay. So I hope you can follow. Just follow the drawing there or the illustration. How did we construct a box and whisker plot? And then you will be able to make or construct your own. Okay, so now outlier. So in a box and whisker plot, this will help us identify the outliers. Again, one of the reason why, or its uses about the use of box and whisker plot, one of its uses is it will help us identify the outliers. One value that is an extreme value, okay? Again, outliers, we define it in our previous video discussion as extreme values. So again, the box and whisker plot will help us identify the outliers in a given set of data. You may see a box and whisker plot like the one below, which contains an asterisk. So as you can see the asterisk there, this shows the extreme value and is placed on the graph but not part of the box or whisker. So in short, the 10 there is the outlier. The asterisk shows, or it shows the outlier. So I hope you can follow. So here's the summary for getting based on the data set given that we have for its box and whisker plot. So you have it there. 80 is the, of course, the first quartile. 70 is the, what I mean is 80 is the second quartile, 70 is the first quartile, and 90 is the second quartile. So that means to analyze this one or interpret this box plot that we have, or the box and whisker plot, we have it there. This represents the 25% of the data, the arrow. And then from 65 to 70. And of course, from in here, 70 to 80, this is the 25% of the data. From 80 to 90, that will describe as the 25% of the data. And of course, 90 to 100 is another, or it represents the 25% of data. I hope you can follow and this helps you understand and interpret the box. So that's how you do it. We're done. So I hope you gain something in this video discussion. And please not forget that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. Okay, math is fun. Do not forget to subscribe my channel and continue to watch my video discussions. Have a great day. Thank you for listening. Until this end.